Hi everyone. So we are going to be discussing and identifying parts of a graph, quadratic graphs especially, okay? So I want us to look at these different graphs, and I've got, some more examples that we can just look at that I want us to go ahead and identify the parts so we can learn to use them when we're looking at this when it's graphed. So this is the equation for this graph. So pretend that you already did all the steps from our last videos about graphing quadratics and you end up with a shape like this, okay? And in comparison, let's look at this graph as well, and this is the equation for this graph. So when looking at these, what are the first things that we notice? So we'll go ahead and just focus on this one, but we can kind of look at this one, okay? So I know that this is, I read a graph from left to right, so I know that this is going down and then it comes back up, okay? So this is definitely concave up because it's, going in the up direction. All right, so we know it's concave up. And then let's go ahead and look at this point right here. This is something that stands out. This is at the bottom. So if this is at the bottom, this is going to be your minimum. And this point is also known as your vertex. Okay? So let's go ahead and look at this one and trying to identify, okay? And we're going to come back and we're going to kind of look at these. So I know that this one comes up and then it eventually falls down. So just by looking at this graph, I see that this one goes up because we're reading a graph from left to right, goes up, and then it comes down. So this would be concave down. Okay, and we also see that this has a negative and this one is positive, looking at our A values like we discussed in our last video. But just a reminder, so we know that by looking at this, we know it's concave down. And also right here is a very important point that we see. We know this one, you come all the way to the top, so this is going to be your maximum. And this is also known as your vertex. So when looking at these, we know that our vertexes are always here, but we know if it comes at the bottom, it's going to be a minimum, and if it comes at the top, it becomes a maximum, okay? So looking at our vertex, let's go ahead and identify this point. So I'm going to start at my origin, 0, 0, and we're going to go on our x-axis, 1, 2, so positive 2, and then we go down 1, 2, 3, 4. Okay, so our vertex is at 2, comma, since we went down, that's a negative, negative 4. Okay, let's go ahead and do the same for this one. We're looking for this point. We start in the middle of our graph. We go to the right 1, so that's positive 1, and then we go up 1, 2, 3, 4. So this one is, since we went right, it's going to be positive 1, and then we went up 1, 2, 3, 4, positive 4, 1, 4. Okay, so we know this is our max, like the tip top of our graph. This one is our minimum, the very low point. Okay, now something else about this graph, and I see our roots. Roots always hit on our x-axis, here and here. So if I follow my x-axis, it hits here and here. Okay, same here. I'm on my x-axis. Oh, it hits here and here. Okay, nowhere else is it going to be. Okay, it's if we follow our x-axis, hits here and here, and if we followed our x-axis, it hits here and here. And these are our roots. So I'll kind of write roots like this. Roots here, and here, and this is a root, and this is a root. These are our roots, okay? I'll just write another root, the word root right here, so we're not combining too much of these two graphs. So roots and roots, okay? They always hit on our x-axis. And now another thing I want us to look at is where are our y-intercepts. So if we followed our y straight down, up, we see our y-intercept right here as well. So this point is both a root and a y-intercept. If we followed our y straight down, up, right here, we have a y-intercept, okay? So these are really, really important. So let's go ahead and identify all of these points. So our root is right in the middle. Our y-intercept is right in the middle. So for both of these, this root is 0, 0. And this y-intercept is 0, 0. And if we look here, this root is going to be 1, 2, 3, 4, 4, comma 0. Okay. Now let's look at this graph here. This root, we go -1, -1, comma 0, because, you know, x and y. So we went -1 on the x, but we're not moving. So it's -1, 0. And this root is 1, 2, 3, 3, comma 0. Okay. And our y-intercept for this one, if we followed our y-intercept right here, so 0, you know, we're not moving on our x, but we went 1, 2, 3. So we know for our y, so our x place we didn't move, so it's 0, comma 3. Okay? And I'll go ahead and write our y-intercept in this blue color so you know that they can both be the same thing. It's okay. All right? So we know that we've identified the very important pieces of our graph. Okay? These are going to be really, really important when you start using these to identify parts of a problem, like a word problem, okay? Just to let you know, because we'll get into this a little bit later, we know that anything on the x-axis is usually going to be time. So I'll write that word. So we know anything with x is going to be time, minutes, seconds, hours, days. And we know anything with our y is usually going to be our height. Okay? How high something is or how low something is. Okay? So, for example, if we were thinking about, you know, jumping off of a diving board, okay? Or jumping into a pool, like water, right? So if we were to pretend that this is water right here, this is right where, you know, you start. You know that if you were to stand here right in the middle, like this is where you stand, right on 0, and you decide to jump in the water, you know that you would end up swimming down, down, down to about right here. And this is what? -4 right here. You would swim all the way down to -4, I don't know, feet. And then you would end up coming back up for air, right? And I would wonder, wow, how long did it take you to get, you know, you started here at 0, 0, you went all the way down to -4 feet, and then you decided to come back up for some air, so you end up back up here, and you're like, well, how long did it take you to get back up here? And we're going to look at our time. So we know it took you 1, 2, 3, also about 4 seconds. You were underwater for 4 seconds, so you went down -4 feet and then back up in a total of 4 seconds. That's just an example. So think about that, right? So let's look at this one. If we were to kind of compare that same idea, okay? Now, really, if this is also time, and this is height, okay? Let's say we're looking here, and we know we have to start right at this point here, right at the 0, 0 mark, right? Like 0, 0 is right here, but we can't go back in time for the x. So essentially, we would be standing right here at 0, 3, right? And maybe, let's just say you decided to throw a ball, and you went up, and the ball went up, and then it went down. So it's like, wait a second, you know, because we're standing here. We can't go back in time, because remember, this is your time. Time only goes forward. You got 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, right? So if you're standing here and you threw a ball, that ball was really high. The highest point, the maximum point, was about 4 feet, but you started at 3 feet, okay? You started here at 3, and the ball was 4 feet high after you threw it. And then it started to, you know, gravity pulls that ball back down, and so then it hit the ground, because this is your root, at 3 seconds. So, the importance of this number right here is going to show you this is the highest that ball was thrown. So it reached 4 feet in 1 second, because anything in the x place is time. And same with this one. You got down to -4 feet in 2 seconds, and then it took you 2 more seconds to get back up. So anything in the x is going to be your time, and anything in your y is going to be your height. Okay? X is your time. Okay? 0 is your height. Okay? Same thing over here. 1 is your time, and 4 is your height. 3 is your time. 0 is your height. Time, height, time, height. So these are just kind of examples of what you're going to have to use this for. Okay?